everyone, we're here to talk about the properties of logs. All these examples are going to be super basic. They're literally just using the law and applying it, but you can always combine laws into one long log and solve for it. But this is just breaking it down by each law. Okay, so the first law, this is your product rule. So you got log base b of m and n, so the product of it, equals log base b of m plus log base b of n. So looking at this one, the first one, log base 5 of 625 plus log base 5 of 25. So since we're adding and they have the same base, we can write them as one log. So we're going to do the log base 5 of 625 times 25. So in your calculator, type in 625 times 25. Hit enter. You get log of 5, base 5, and 15,000, right? 15,625. Sorry, the pen's being a little weird today. Okay, then you can go ahead and hit math, alpha, math, and then it'll give you to where you can set up your log and just type in your calculator just like you see it. And then hit enter and you get that this is equal to 6. So 6 is your final answer. Alright, the next one, log base 4 of 2 plus log base 4 of 32. Again, they have the same base, so we can add them, or we can multiply our arguments. So we're going to have log base 4 of 2 times 32. Okay, hold on one second. My computer chose it. Oh, it went away. Never mind. Okay, now you're going to multiply 2 times 32, which you get 64. So we have log base 4 of 64. And then again, you can hit math, alpha, math, type it just like you see it, and you end up getting it's equal to 3. Okay, now if you get them to where they have different bases, so say you have log base 4 and log base 5, since they're different bases, you cannot apply this rule, so make sure you're paying attention. Alright, next one. This is your quotient rule. So log base b of m divided by n is equal to log base b of m minus log base b of n. So looking at the first one, log base 2 of 32 minus log base 2 of 4. They have the same base, and we have subtraction in the middle. So we're going to divide 32 and 4. So we'll have log base 2 of 32 divided by 4, which we know that's equal to 8. So this is log base 2 of 8. And then we know that 2 cubed is equal to 8. So this is equal to 3. Alright, next one. Log base 7 of 49 minus log base 7 of 7. So again, they have the same base, and we're doing subtraction, so we're going to divide. So we got log base 7 of 49 divided by 7, close parentheses. We know 49 divided by 7 is 7, so we'll have log base 7 of 7. And then anytime you get the base and then it's the log of the base, it's always going to equal 1. Okay, if you're confused at any point so far, be sure to pause the video, go back, and re-listen to each step as we go through. Alright, next one. Log base b of m to the n is equal to n times the log base b of m. So in other words, what this is saying is anytime you have something inside, so your argument that's raised to an exponent, you're going to take your exponent and make it the coefficient. So the first one, log base 3 of 81 squared. This 2 right here is going to move to the front. So we're going to have 2 times log base 3 of 81. And then you're going to solve. So you can type in your calculator just like that, or you can solve log base 3 of 81, which is 4. So this is 2 times 4, and 2 times 4 is equal to 8. So that's your answer. Alright, next one. Log base 5 of 1/5 to the third. So again, we're going to take this 3 and bring it to the front. So we're going to have 3 times the log base 5 of 1/5. And then with another rule that we have, log base 5 of 1/5, that's equal to, since this 5 is raised to the first power, it's equal to the opposite of positive 1, which is negative 1. So we have 3 times negative 1, which equals negative 3. Alright, next one. Log base b of 1 over b to the a is equal to the opposite of a, or the negative a. So the first one, log base 2 of 1 over 2 cubed. The 3 is our a, so this is equal to the opposite of positive 3, so it's negative 3. Next one, log base 4 of 1 over 4. So any number that does not have an exponent, it's automatically a 1 on top of that. So the opposite of positive 1 is negative 1. Alright, last one, log base 3 of 3 to the negative 2. So I could always rewrite this as log base 3 of 1 over 3 squared. Well, technically you should, but no matter what, you're going to get the same answer. So say you rewrite it as log base 3 of 1 over 3 squared, then you're going to get you'll get negative 2, which, yep. Let's just check this one real quick, because I might have messed up. So math alpha math, base 3 of 3 to the negative 2. And you get negative 2. So you do need to move it down, because say you didn't move this down, and you just went with this and called this your a. Then you would get negative of negative 2 to where you get positive 2. So you got to make sure that if you have a negative 2 and it's on top, you have to take this fraction, this, and move it to the bottom. Okay, so you got to do exactly what we did here in the green. Alright, I know that last one was kind of confusing. If you need to pause, rework it, go for it. Oops, wrong direction. Sorry, guys. Okay, next one. Log base b, so any base of 1 is always equal to 0. And the reason for this, if you were to change this to exponential form, it would be b to the 0 equals 1, which we know anything to the 0 power is equal to 1. So, for instance, the first example, log base 3 of 1. So, say we convert to exponential. 3 to the x has to equal 1, x has to be 0. No questions asked. Next one, log base of 1,000 of 1 equal to 0, no matter what. Next one, log base b of the base is equal to 1. So anytime, as I said earlier, you take the log base of whatever of itself, it's always equal to 1. So what this is saying is b to the first is equal to b, which we know that's true. So first example, log base 3 of 3. It's 1, guys. That's your only option. Log base 1,000 of 1,000. Again, it's 1. Okay, this is your change of base formula. Yes, you should use your change of base formula, but most of the time, at least you need to recognize this, but most of the time you can just use your calculator since y'all know how to do the math alpha math or the math window 5. Both of those do, all three of those do the exact same thing. But I'm going to go ahead and show y'all how to do change of base. So the first one, log base 5 of 625. Our x is going to equal to the log of our argument, which my argument is 625, divided by the log of our base, and our base is 5. Now remember, a log without a base already on it is an implied 10. And on your calculator, you can just hit the log button and it'll give it to you. So I'm going to type in log, then 625, close your parentheses, divided by log of 5. Hit enter. I get this is equal to 4. Alright, next one. Log base 5 of 47. Again, we're going to do it the same way. So we're going to do x is equal to log of our argument, which is 47. Sorry, my pen's being weird. Over log of our base. So log of 5. So again, I'm going to type it in. Log of 47 divided by log of 5. Hit enter. And now we're going to the third decimal place. So this is equal to 2.392. Okay. Alright, next one. You have a base raised to the log of the base of a. That's equal to a, because the base and the log, this part, they undo each other. So the first one, 12 raised to the log base 12 of 40. Guess what, guys? Your a is 40. It's equal to 40. Next one, 600 raised to the log base 600 of 5,000. Again, your a is 5,000. That's your answer, 5,000. Alright, that's all I have. I hope this helps. If you have any questions, feel free to go ask your teacher or come ask me, and have a great day.